we get started here. So welcome everybody to the Golden Design Rules Essentials course. Thank you for joining us today. Today we have with us Andrew McDonald, PAC's Project Manager, and Dan Lance, PAC's Canada Director. Dan will be the lead on our course today. Andrew will be here as supporting and also monitoring the chat box. So we do encourage questions as they arise during the presentation. You can either raise your virtual hand if you'd like to ask a question out loud, or use the chat function, and Andrew will moderate those back to Dan. We will be also sending out a survey towards the end of the course to all of you. We do, as this is our first course, we really would appreciate your feedback and submitting that. It'll only take you a few minutes and that would be wonderful. So with that, we have a lot to cover today, so I will throw it over to Dan. Dan, welcome.
Thanks, Lindsay. Good morning, everybody, and welcome. This is our first run at the Consumer Goods Forum Golden Design Rules within the Canadian context, our training presentation. So again, we really do want your feedback. If there's something that you see that we're missing, please let us know. If there's something you'd like me to elaborate on, please let me know, and we'll do our best over the next 2 hours to make sure everybody understands what the GDRs are all about. And my screen just froze. Of course it did. There we go. So, introduction. Consumers are looking for more sustainable packaging. In fact, today, 5 years ago, it was quite interesting. I was looking at a study, and recycling really wasn't much on the radar screen for consumers. However, today, 64%, almost 2/3 of all consumers are looking for packaging that's recyclable, or packaging that's reusable, which really thrills Andrew. And if you ever want to get into a great conversation with Andrew, talk to him about reusable packaging. They don't want to see packaging, over packaging. Compostable, biodegradable packaging, we're not going to get into that today. It's part of what the Golden Design Rules will be looking at in the future. But for now, we're going to be focusing on more on the recycling side. They're looking for packaging made from renewable resources and materials that are easy to move, easy to dispose. Interestingly, today, now, looking at this from a business perspective is not moving to packaging which is sustainable is going to cost companies sales. So the Golden Design Rules within the New Plastics Economy, the Ellen MacArthur Foundation released New Plastics Economy a number of years ago. And as you can see, it's got the main, what I call the racetrack, the large loop here on the screen. And what the New Plastics Economy is all about is once material is in the economy, the idea is to keep it in the economy as long as possible. So don't let it leak out. And leaking out, of course, we all talk about ocean plastic, for example. That would be a form of leakage. So really, really wanted to avoid number 2. On the interior, the small training track, as I call it, the reuse track is where you keep the material in use as many times as you possibly can. It might, of course, it will be heavier in weight, take up more resources, but it becomes more environmentally preferable if the number of times you reuse it continues to go up. Like some of the new packaging that's in the Loop program can be reused 100 times. Well, 100 times now, all of a sudden, it makes single-use materials almost not look like a very good option as an alternative. So idea, keep everything into the circular economy as long as you possibly can. So just looking at the recycling rates across Canada, I'm not going to go through each of these, but these are the main categories that you see that most people are aware of. Number 1, PET bottles and containers. All plastic deposit containers, they're separate. And you'll notice that plastic deposit containers do better than any of the plastics. They're consistently above 50% for regardless of what the plastic container is. But we do have other materials within the stream that are doing better than 50%, which is the Consumer Goods Forum and the CPP goal of 50% recyclable for now. And then, of course, moving to 100% recyclability in the future. So we've got PET bottles and thermoforms and HDP bottles that are all over 50%. So that's good. We're pretty good. Then some of the other materials, we've got HDPE tubs and lids, LDP tubs and lids. They're close, they're getting there, about 40%. We've got polypropylene at almost 40%. And then we've got some of the other plastics such as expanded polystyrene And degradable plastics, they're down much lower. The non-expanded rigid polystyrene, that's a rigid container. So for example, a snap-off yogurt cup would be an idea of a non-expanded rigid polystyrene. Expanded polystyrene is cushion packaging, for example. So we're not doing too badly in Canada, but we're not doing as well as we can be. And so that's the focus of, one of the focuses of the Golden Design Rules, is to see how we can do better. My apologies, I got a frog in my throat this morning. So now there are 9 Golden Design Rules. We're not going to do them all now. This is just an introductory slide to them. They cover off, you can see that half of the Golden Design Rules, 51%, cover off flexibles. So flexibles are the biggest area of growth in plastic packaging. They're growing by double digits a year. And as such, the Golden Design Rules wanted to address that. And there's a specific rule just for that. Oh, there's a number of them, but there's one just specifically related to increasing the recycling value of flexible packaging, number 6. We are going to go through all of them, so don't worry about getting all of this down right now. PET bottles are addressed by Golden Design Rule number 1 by itself. The 2, 4, and 5 plastics are addressed by number 2, as are the other plastics, and I'll explain what I mean by that, because the other plastics are now looking to be excluded. So the focus is going to be on 1, 2, 4, and 5. So we're going to get into that, the PET trays and what we call thermoforms. Think about when you go buy your salad from your produce aisle. That's a PET thermoform. That's addressed by Golden Design Rule number 5. And then some of the other rules, number 7, look at increasing the value of rigid packaging. 8 is business to business in terms of packaging use. For example, the reusable plastic totes. And number 9 is unpack instruction. And we're going to go through all of those today. So why do we have the Golden Design Rules for Canada? It creates consistency in plastics used to allow for economies of scale. One of the things that recycling really needs to be viable is that you don't recycle it in small quantities. It gets very expensive. We'll get into it more later. But when you're trying to sort plastic, if you've only got a little bit and then you have to go put in a $250,000 piece of equipment, it makes the cost for capturing that material very expensive. So by focusing on the plastics with the most uses and the highest values, then what you do is create even greater economies of scale, create opportunities for more businesses to come into the marketplace for recycling the material. I mean, after it's been captured by the recycling facility, the consumer in the recycling facility. And so the focus is really on maximizing the value of the plastic within the stream. The idea is also to move plastic packaging from non-recyclable or not recycled to recyclable. Again, we want to increase the yield at the end markets. For example, a bale of what people might understand is what they call 3 to 7 plastics. So that's typically all your tubs and lids and things of that nature. All of that goes to a different market than the bottles do, number 1s and number 2 bottles. But their yield at the end market is very low. It can be as low as 45, 50%. And because they only want specific plastics, the other ones aren't generated enough volume to make it worthwhile to capture them and put them back into more recycled plastics. Doesn't mean they throw them out, by the way. That's a different discussion. With increased use and capture, increased material for recycled content applications. One of the Canada Plastics Pact, and by the way, thank you very much to George and the CPP for the information that we have here. It's all tied together. This is a co-sponsored event with the CPP. And pardon. So what we're showing you here is what is all part of the Canada Plastics Pact as well. So one of the other goals of the CPP is to have 50% recycled content. So when you have more material captured, you increase material available for recycled content applications. And that's really critical because right now the supply of recycled content plastic is much lower than demand for recycled content plastic, to the point where recycled content plastic values are increasing extremely high points. And for the first time in 30 years that I've been doing this, HDPE bottles, natural, so think of a milk jug, vinegar bottle, something like that, they're worth more than aluminum cans, which have always been the golden child of a recycling program, with used beverage containers, pop cans, being worth the most, but not today. Right now, HDP natural is worth more than aluminum. So we really need to capture more material to be available for recycled content applications. Sorry, I'm just quickly checking the chat box. Lindsay, it's your comment. So I have no questions right now. So before I get into the golden design rules, are there any questions at this moment? Okay. So the first golden design rule is to increase the recycling value in PET. Now, this is just PET bottles. This does not relate to PET thermoforms or PET trays. So golden design rule is just PET bottles. The big thing with here is uncolored has the highest value. Now, uncolored means no opaque colors. You can have light blue or light green in PET bottles, preferably clear though, as in think of the Coke bottle. It's perfectly clear, as opposed to like a 7-Up bottle, which is light green, or a Clearly Canadian, which is light blue. Both of those are acceptable, or all three of those are acceptable, but the preference is uncolored PET is preferred because it can go into the most applications after being captured for recycling. But there's more to it than just that. So clear PET is in the highest demand. There are a number of companies, including Coke and Pepsi. There are others who want bottle for bottle. They want to capture one bottle of PET for every bottle of PET they put in the marketplace. Or they want 100% recycled content. They don't necessarily call it bottle to bottle. And a shout out, that is Coke's program. So so there's no confusion between Coke and Pepsi. But the idea is to get the most bottles in, so we can put the most recycled content into the Coke bottles or the Pepsi bottles or other bottles. Ice River Springs is an example right here in Canada, in Ontario, where they take in recycled PET and they put it into the single-use water bottles and other multi-use or larger scale water, and they're putting in 100% recycled PET. So huge demands for PET, but they want it clear. Opaque PET is not recyclable into anything other than another opaque PET. So there's lots of opaque PETs, and I'll show you a picture in a second. However, you can't make PET into clear PET. In other words, you can't remove the opacity and you can't remove the color. Not with mechanical recycling. You will be able to do that with chemical recycling, but we're still probably 5 to 10 years away before we're going to see opaque PET being able to be put in with PET and then be removed chemically. The colors removed chemically from the mix so we can get back to the PET resin. Another thing that people aren't aware of, but PETG, so that's glycol modified PET, is not compatible with PETE. So the E is just terephthalate. This is PET, same thing, but glycol modified. You see PETG, for example, in juice, and it's got different characteristics which are more impregnable to acids, et cetera. So they use that. But unfortunately, it's completely non-compatible, and so the move is to not use PETG anymore. So very quickly, acceptable. These are generic pictures, by the way. We don't call out, except PAC, we have our award winners for a couple of categories to show you what's possible from our PAC awards. So acceptable, clear PET. The pump on top is not an issue. That's assuming it's not made out of polystyrene, which generally they're not. They're made out of polypropylene. And so that can be removed from the PET. So that's not an issue. But you see the ones on the right, these are opaque PET bottles. And this opacity that's in here, regardless of the color, even the white one, can't be removed from the PET bottle. And as such, it isn't recycled and it will cause problems with the PET recyclers. They do have to remove the opaque bottles from the clear bottles, whether they're clear or no color, clear green or clear blue. They all need to be, this all needs to be removed. Black PET, all the colors of PET need to be removed before they can recycle the PET clear into more recycled PET clear. So the other thing is that you need to avoid the other part of Golden Design Rule number 1 is the application for consumer product goods manufacturers is avoid labels which can cause problems in post-collection and market values. So no PVC. PVC looks just like PET when you hold them up to a regular light. If you hold them up to an ultraviolet light, they fluoresce. You can actually find it very easily in a facility to separate the PET from the PVC, but in some facilities that are smaller, they're still using manual sorting, not as common as it used to be. But there can be real problems with keeping the PVC out because one bottle of PVC in a bale of PET bottles can cause a problem for the recycler. PVC DC is just another form of PVC. I've already mentioned PET and PLA as well. Looks like PET, but all of those now in a label format should not be used because all of those, when they do the washing cycle to try and separate the PET from the lighter fractions, which are the polyolefins they're called. So it's polyethylene, so HDP, LDPE, and polypropylene, they all float, but these all sink. So you imagine if you've got any of these contaminants in terms of labels in with PET bottles and the PVC sinks with it, now you've got PVC in with the PET, and then it's going to cause a problem when it comes time to extrude it to try and make a good PET, a recycled resin.
Dan, Andrew here. Yes. Just a quick clarification for the group. Difference between PET and then when you add the E. You mentioned it briefly, but if you could just, once again, just clarify that one.
Yeah, PET and PETE are the same. I just put the PETE on there to differentiate it from PETG. Because PETG is typically shown just as PET as well. It isn't shown as PETG necessarily, but there's a number of different types of PET. In this case, we're talking about just the base version like you see in a single-use water bottle, soft drink bottle, things of that nature.
Got it. Thank you.
Okay, and you can tell, just if you want to know the difference and how you see the difference, if you hold two of them up and you look at the bottom and both of them say PET, if there's a dot in the center of the bottle, that's a PETE bottle. If you see a line across it, or what we call a smile, straight across here, across the bottom of the bottle, that's a PETG bottle. And so we don't want the PETG bottles, we want the PETE bottles. If you're using a full body sleeve, shrink sleeve for PET, they're acceptable only if the color can be removed. In other words, the ink can be washed out. We can't have the ink being left in suspension that goes with a PET, otherwise they get marks and spots and other issues when it comes time to extrude the new PET. So full body PET bottle labels on PET are fine in terms of being able to find the PET, but only okay if you can keep the ink out of it. Generally speaking, though, any label on a bottle should not exceed 75% of the bottle. Otherwise, what happens when it goes through the recycling facility is the facility's equipment, the optical sorters, will find the label and not the bottle. We want to be able to find the bottle. And their algorithms they've got built into the optical sorters allow it to see the top and the bottom of the bottle. And they can say, okay, I know that's the label. I don't want to focus on that. I only want to focus on the top and the bottom. But they need about 1 inch, give or take, 2.5 centimeters top and bottom. So not as much as it used to be. That's actually a little less than that now. But the idea is that they want to be able to see the resin of the bottle, not the resin of the label, to do a proper separation with an optical sorter. And optical sorters are very flexible. They can be programmed to find each of the 7 plastics and then even colors within the plastics. So it's not a problem with finding it. Like PLA is just one of the number 7 plastics. There's no problem finding PLA or PHA or PETG or PVC, no problem at all in finding it. But if it's a full body sleeve on it, then it's going to think it's that bottle and not the PET bottle that's underneath. And that's what we want to find to maximize recovery, consistent with the Ellen MacArthur Foundation. Keep it in the circle, right? Keep it on the racetrack. Using polyolefin-based labels or paper labels, which are water soluble, to remove adhesive is a better choice. So they come right off. The polyolefins will float. The paper labels will fall apart, disintegrate, and they'll be washed away. Again, though, keep the label not to the full body, regardless of what you're using. Nylon barrier layers are a real problem for PET recycling. There didn't used to be a lot of nylon barrier layers. Again, it was found in some juice bottles that were PET, not PETG. But it's becoming more prevalent in the marketplace for carbonated PET beverages. And so the nylon that's in there, just speaking with an end market in Ontario, call them out, they're doing a great job, with Ice River Springs and talking to Crystal, the nylon barrier layer is really starting to cause a problem for them because nylon doesn't melt at the same temperature as PET. It melts at a lower temperature. And so when you get up to PET temperatures, it starts to burn. And of course, that causes problem for the quality of their recyclate that they're making their new recycled PET bottles from. So we need to find an alternative to the nylon barrier layers in order to maximize the value, again, consistent with the Gdrs, maximize the value of the PET. So that's gold design rule number 1. Any questions on that one?
So far, the chat is quiet, Dan. You're
wow,
comprehensive job. Oh, we do. Hang on.
I have a question.
Question is, isn't paper a problem? So
if the paper isn't, if it washes away. Now, realistically though, if everything was covered in a large paper label, then you're going to get into BOD loading issues when it comes to washing the bottles. If the paper doesn't wash off the bottle properly, Judith, then yes, it will also be a problem. Regardless of what the label is made of, it has to completely be able to be removed from the bottle itself. So the paper can be an issue if it's too much. The other thing that can be an issue, of course, is the adhesive that is used to hold the paper label or hold the plastic label or whatever it is onto the bottle. So sometimes you get a little plastic label and then there's an adhesive strip. It gets stuck on, the plastic label goes around and they put the adhesive on the end and they seal it to the bottle just in a strip form. Sometimes that adhesive is so strong that that label won't be removed from the bottle. That's what causes the problem. The same thing happens with the paper. So as long as there's not too much paper, because that causes a different issue, and if it doesn't move into suspension and disappear, again, anything that's a contaminant when it goes through the extrusion process is going to cause a problem. Okay, you ready to move on, Andrew?
ready to go.
Okay, great. Golden design rule number 2. This one's got a lot going on here. So just this, the little green boxes by the way at the top are they're straight out of the Consumer Goods Forum presentation of the golden design rules. So you're getting it straight from the source. So in terms of the golden design rule number 2 is we need to remove the problematic elements from plastic packaging. No undetectable carbon black. Now, before everybody goes, oh my God, we can't have black plastic. No, that is not what it's saying. Now, I'll be honest, there's way too much black plastic in the marketplace just from the perspective of running it through the recycling facility. And I'll get into that in a minute. But no PVC, no PVDC, no EPS or PS. Now, EPS is cushion packaging, which really isn't a packaging form for liquids or solids. It's more of a cushion packaging. This is silent. You'll notice it doesn't say anything about XPS, which is the meat tray. The golden design rules are silent on XPS. In a very early time when we were developing the golden design rules, XPS was excluded. It was actually listed at the bottom in the footnote saying excluding XPS meat trays. Now they don't exclude it per se, but they don't include it either. So they're silent on it. For now, XPS meat trays are fine. You can continue to use them. Now, from a recycling perspective, I will tell you that if you're going to use them, please use white only. White is the color, unless it's going back to a chemical recycling like Pyrowave or polystyrene, for example, in Montreal. The black or the colored polystyrene is of little value, whereas the white can be sold. It's actually quite a valuable plastic, but please keep it in white. No PETG, we've already mentioned from golden design rule number 1. Yes, there is crossover. You saw that from the introductory slide, number 1, 2, 4, and 5 fall across a number of golden design rules, and a number of golden design rules fall across a number of packaging types. So, and finally in this one, no Oxo Degradables. This does not say no biodegradables, but again, from the perspective of maximizing the value in the recycling system, no biodegradable plastics should be included anywhere within the network of plastics that are being put into the marketplace today to maximize value, because biodegradables end up in the same place as the non-biodegradables. And as such, that causes problems. We don't want biodegradable PET bottles mixed in with recyclable PET bottles, because then we end up with problems with the recycled PET. Okay, so, but the golden design rule, it says Oxo Degradable. The reason it was focused on Oxo Degradable is just a little context. I could have said this right at the beginning, but the golden design rules were developed by an international committee. The two chairs were Loblaw and Unilever, but they were developed from the perspective of the entire world. This is not a Canadian, this is not an American, this is not a EU only, this is everybody was involved, everybody was welcome at the table. We all worked together. So some of the elements of the golden design rules are more applicable to what's happening in the EU, and therefore they're on the list as what to be included or not included. And I'll show you an example of what they've included where we really don't want it included a little later in golden design rule number 6. So Oxo degradables are a problem in Europe, and they purposely called them out in the meetings and said, we don't want them. That's fine. So they're there. They're not really seen much over here on this side of in North America, but they're still part of the golden design rules, and as such, they stay in as it is. So same call out, but looking at a little more, no biodegradable plastics at all.
Dan.
Yes.
You're here. A couple of
Lots of questions. Oh, we're going to get all, oh boy, look at them all.
Yeah. So we'll go back. Well, a question regarding golden design rule number 1. And with regards to labels, what is the recommended adhesive to use?
A water-soluble adhesive is the best choice, or a light caustics dissolvable adhesive is another choice. So not a problem if it is that. Now, specific brand names of adhesives, I couldn't name any of them for you. If you want more information on the adhesives, go to the APR Plastics Design Guide, which I will, there is a link to it in here, which also you can know where to go to get it. In there, they talk at great length about adhesives as to what should be used and what shouldn't be used. The idea is that the wash cycle is typically, you know, hot water based, maybe a slight caustic solution to get the adhesive broken down. Anything more than that, now you're starting to introduce chemicals into the plastic, and you don't want to be doing that. You want to keep it clean and light and easily removed, so it all comes off in a reasonably quick process.
Got it. Very good. And then to rule number 2, back to rule number 2. The question is, isn't EPE an issue? And even for my benefit, could you define EPE?
Yeah, what's EPE?
Oksana, if you have a moment just to...
Oh, it's expanded polyethylene.
Yes.
Yes. Yes, expanded polyethylene. Yeah, I hate that. Sorry, that's just a personal opinion. That's not in the golden design rule. Sorry. No, George and Jim, don't yell at me, but no, I hate expanded polyethylene because it floats with, and if it goes in, people put it in with the polystyrene, and you cannot hot melt or cold press, which is what you need to do to get polystyrene to market. In most instances, you can't put that through either and have it work coming out the other end. So expanded polyethylene, yes, that's an issue. Not recommended. The golden design rules are silent on EPE, but from a recycling perspective and trying to get it through the recycling system and get it somewhere, yes, because it'll end up with the polystyrene mix. It will not, if it comes through the MRF generally, it will be pulled off as a foam, trying to train people that no, you leave it and then it's to go out with the polyethylene. It just doesn't go where you need it to go necessarily, such that it maximizes the recovery of that material. So yes, it is. So I would prefer if everybody avoided it. Same with expanded polyethylene or PET too, and PET film. Oh, there's lots of stuff we could get into. My goodness, we could talk for hours. So go ahead, Andrew.
Good for now. Onwards.
Caps on bottles. No, there's no problem, Manuel. Not a problem at all. The bottles stay on, but when you go and they shred them and wash them, the bottle caps are are PP, polypropylene. In most instances, they float in the water, whereas PET sinks, and so that it's an easy separation. And then they can actually capture the polypropylene for recycling and the PET for recycling both. So no, Sonny, it's not a, oh, sorry, man, I know Manuel, so sorry about that. Yeah, no, it's not a problem at all. Anything else? Oh, okay, yes, we got the labels, adhesives. Okay, great. Sorry, I'm just following along the chat there, Andrew.
Yeah, good.
Next. So black plastics is a growing problem in some perspectives. It's not a problem in others. It all depends on how you want to look at it. Unfortunately, black plastic, when you put a black plastic container on a black plastic or a black rubber belt in a recycling facility, a MRF, material recovery facility, the system can't see it for the most part. But there are a couple, and I do mean a couple, literally a couple of facilities that can sort it out. The technology is now available. It's extremely expensive. One technology can actually see through a different combination of light spectrums to see the black plastic. Another one waits until the black plastic actually just falls off the end of the belt. And then when it's in air, it can see what it is, and then it can do something with it in terms of ejecting it into it. But unfortunately, these specialized technologies can only be done on a one resin at a time basis. And when you think about the fact that black plastic comes in one, so that's PET, number 2 is HDP, number 4 is LDP, number 5 is polypropylene, and number 6 is polystyrene. They come in all of those resins. All of a sudden, you're now adding in millions of dollars in new equipment into a recycling facility to capture black plastic. However, unfortunately, even if you only put one in and said, get me all the black plastic, you would still get one that creates a blended stream of all the resins together. Now you send this to an end market and they say, okay, great. They can deal with it. There are methodologies in the marketplace that don't require even optical sorting. There's chemical methods, and I don't mean putting chemicals in. It's all comes down to specific gravities of liquids. You can actually separate out the different polyolefin grades from the other grades, even beyond just zinc float for 2, 4, and 5 against number 1 and 6. So it's possible. Black plastic is being used. It is being recycled. It isn't being recycled everywhere, but it can be. Where the golden design rules were going was, yes, black plastics are fine, but please make them discoverable. Now, discoverable with typical technology means that when it goes underneath a light, the optical spectrum doesn't see black. It actually sees a different color. And there are companies out there, Unilever's one, and I call out the good people. I won't ever throw anybody under the bus, but the good people, like in some Unilever black plastics, what they do is they put a colorant into it that actually shows up as blue in a recycling facility. So they can sort the black plastic as blue plastic when it comes through the optical sorter for their HDP bottles. So you can find it. Now, if everybody was to do that, then we could sort the black plastics into the different resins. It wouldn't be an issue. But unfortunately, the vast majority, and I'm talking probably 98% plus of all the black plastic that comes through a MRF nowadays, is not recognizable by its resin. And as such, it all goes out as a lump. In a lot of MRFs, they're not using any optical sorting at all because it's brand new technology. It's extremely expensive. So they manually sort it off, either by manually pulling off the black containers or pulling off everything else and leaving the black containers. So very, very expensive process. When you think about somebody can only pick off, if it's one person, they can only pick off 60 pieces a minute. And when you start looking at the amount of black plastic there is in the marketplace, it's a lot. It's well more than 10% of all the plastic in the marketplace right now, my guess, just from watching it going through recycling facilities. However, by not having black plastic, you're sort of going, well, hold on, you're defeating the purpose, because when you take HDP and all the different colors that are out there, unless the end market is doing high grading of the HDP, in other words, color separating, say the white or the white and the blue from the orange and the yellow to make different colors of HDP, pardon me, the HDP gets blended together. What does it create? It creates a gray or a black pellet. So we're creating recycled content in black, which can be used in containers, non-food applications. So you don't want to take away black plastic, but we just need to do more to help keep it in the circle, keep it in the circular economy, right? By making it discoverable so the recycling system can actually capture it and make sure it doesn't go off as just part of the residue stream. So the idea is to move to 1, 2, 4, and 5 plastics. The first bottle that you're seeing there, that's a PVDC bottle, and you can't quite see the stripe across the bottom, but trust me, it's there. Tim Hortons was an award winner for PAC. The reason they were award winners is they moved from number 6 plastic for their lids to number 5 plastic. There are lots of other examples out there of companies that have moved from number 6 to number 5, especially in the coffee pod industry, where they're moving from 6 to 5. Avoid PVC, which is very common in automotive and for hazardous chemicals. It's got different barrier properties, which are really good for it. Avoid PETG, which is the first X, or combinations of plastics, multiple plastics, which is what we've got down the lower left, where there's so many different plastics being used. Particularly, you see it in cosmetics and applications with acids and chemicals, et cetera. Moving to something that doesn't have that combination in, or in the case of the one on the right, it was a paper-based package, which is completely getting out of worrying about it within the CPP perspective, right, of managing single-use or non-recyclable plastics. Move to something that is a different substrate, a different media, and have it recyclable then. So, eliminating problematic, and that's the words are from the Golden Design Rules. It says problematic. I don't like the word problematic. Technically, honest to goodness, all the plastics are fully recyclable. You can sort and recycle PVC, other polystyrene. It's just that they don't get it because we don't have economies of scale for most of them. And as such, what they're saying is the PVC, the polystyrene, other are replaceable for the most part. There are examples where you can't. The medical industry is excluded from the Golden Design Rules because they need PVC for certain applications. And as such, they're not captured here. But for the most part, for consumer goods that you and I are purchasing, PVC can be replaced with PET, for example. So the idea is to focus on the green, the materials in green here. By the way, these are not allowed symbols. You're not supposed to use the Mobius loops with the numbers in them anymore. You're supposed to just use a triangle, but I couldn't find a triangle with the numbers in it that were nicely color-coded for me. So focus on 1, 2, 4, and 5. Eliminate or look to replace number 3, number 6, and number 7 plastics. All of the applications of PVC, polystyrene, and other, with the one exception being XPS meat trays. But bear in mind, remember, this is a global initiative. I'm going to call out polystyrene because Canada is further ahead than most jurisdictions when it comes to looking at polystyrene recycling. We can capture the polystyrene. It can be recycled, even if it isn't going to Montreal, for example, to the chemical recycling facilities. There's a facility in the Northwest of the United States that can take polystyrene and recycle it through gasification. There are mechanical means of capturing and recycling polystyrene, which is being very successfully achieved in British Columbia, and it goes to where they densify it and they can mechanically recycle it. So it isn't that polystyrene is not recyclable, but for now, what we're doing with the CPP in the application of the Golden Design Rules for CPGs is to focus on number 1, number 2, number 4, and number 5. Now, bio-based plastics are okay in the 1, 2, 4, and 5, but bio-based means that they're coming from renewable sources, does not mean biodegradable. So the one that everybody will be most familiar with is the Dasani water bottle. They call it their plant bottle. 70% of that bottle comes from renewable sources. That's the PE, the polyethylene portion. The terephthalic acid portion, that's 30% of the bottle. They haven't figured out how to make it from renewable sources yet. But that bottle is a 100% recyclable, very acceptable bottle in the recycling system. It does not degrade if you put it in a composting system. But unfortunately, the perception is it's also a degradable bottle. It's not, but it's bio-based. Bio-based is just fine. Again, the other number 7s that are considered as compostable, the PLA, PHA, other number 7s are specifically not discussed at this point in the Consumer Goods Forum Golden Design Rules. They are part of the discussion around compostables, which will be coming in the future. And George has got it on the radar screen for the Canada Plastics Pact, so it will be coming up for discussion sooner rather than later to be addressed here in Canada.
Dan, two things. So we've got a question in the chat. Maybe if you could take a peek at the chat. It's a longer one. Why don't countries revoke recyclable status for products like plastic of certain recycled numbers where it can't be recovered economically?
Okay, I'm going to ask the loaded first question is define economically, because other than currently, and this is a once in my lifetime type time frame when HDPE is now worth more than aluminum cans. But generally speaking, other than this year, plastic has always been more expensive to collect and process and get it to market than what it's worth at the end market. So in other words, what you're going to get paid for it. So if anything that's a negative market value, is that considered economical, or is that considered something we should be doing as part of society? And before you, I'm not asking you to answer the question, it's a rhetorical question, but bear in mind that with the exception of aluminum cans, and today HDP natural only bottles, every single other material that's in the blue box or the cart, regardless of where you're living, costs more to capture through the collection system and process it than it's worth at the end market. So that what that means is that if you really look at it, nothing is economical in terms of turning a profit by recycling. Every single material in the system costs more to recycle than what it's worth from an end market perspective, other than the current situation with HDP, and typically aluminum cans are worth more than what they cost to recycle. So that would be my question is, what is economically? Now, in terms of recyclable status, it all depends on how you look at recyclable status. Because, for example, in Canada, the rule through the Competition Bureau says that in order to be called recyclable, the plastic has to be capturable and be able to be sent to a market by at least 50% of the population of a given jurisdiction. In all honesty, other than multi-laminated plastic pouches, all plastics are considered by strict legal definition recyclable in Canada, because what we do is we collect everything. And the reason we do that is people are not going to sit there and grab a plastic container and turn it over and look at the bottom and go, okay, what number is this? No, they don't do that. What they say is, oh, I'm allowed to put plastic in my blue box. And so what they do is anything that's plastic, and I do mean anything that's plastic, kids' toys, rubber hoses, I know those aren't plastic, they still go in anyhow. All of those materials end up in the blue box. And then what we do is we rely on the recycling facilities and or the end market to separate out those that are of a marketable nature. In other words, that the end markets want to use them because they're at a scale they can use. So where do you draw the line in terms of what is decided as recyclable versus not recyclable? In Canada, everything's recyclable. In the States, they're a little more strict and saying that it's 60%. And what they do down there is they're more likely to say no 3 through 7, or maybe only 1, 2, and number 5 plastic, polypropylene, which is gaining popularity in the US for being captured in the recycling system. So it's not quite a simple question to answer in that sense by in terms of definitions of recyclable, because it is recyclable. In terms of practicality for recycling, that's a different question. And the concern is that if we start saying, no, you can only put 1, 2, 4, and 5, and you can't put 3, 6, and 7 in, we're going to lose number 1, 2, 4, and 5 from being captured, because it's too confusing for the public to sit here and go, now I got to start looking at the bottom of all my bottles or all my tubs, and where's the label, or where's the Mobius loop with the number. And on some tubs and lids, some of them it's on the inside, which means you got to eat the product first. Others, it's underneath, and if there's a little bit of goo on it, say from your yogurt, and you're trying to look at, now you got to clean off the lid to find the nut. It's just too hard for the public to do it. And as such, everything gets thrown in and they rely on industry, the MRF and the end market to figure out what is going to be recycled. I hope that's a long-winded answer.
Good. No, Dan, all good. And just a quick time check. So we're just shy of 10 to the hour.
Whew, okay, we got a long way to go, folks. So I'm gonna press on unless there's other.
Put on your seatbelts.
Yeah. Okay. Number 2 is the one that takes the most time to discuss because there's so much going on there with respect to what plastics are the focus of the future. So golden design rule isn't as much about removing plastic or focusing on specific plastic for the recycling system, but rather reducing the amount of plastic that's used within primarily flexible packaging types. Now, it doesn't mean you can't look at dry groceries and look at what you're doing. So for example, a cereal box that's, this big and this shape, maybe if you reconfigure it to this big and this shape, right, then you can reduce the headspace loss. In all instances, it can't be more than 30% across all the categories that are listed there. So it's affecting pouches, bags in boxes. So the dry groceries, the cereal example, detergents, all these things. They're saying now, what can you do to make sure that the amount of packaging space that is just space within the package, in other words, not showing product, is reduced so it's no more than 30%. Now, there's a very strict, in Canada, it isn't just Canada, there's other places. This is slack fill for North America. I'm not going to read it to you, but there's strict rules in terms of how to do it, what to look for. I actually show the picture of it on the next page of how you measure it in terms of your packaging. The same rule applies to all pouch packaging types, whether it's stand-up pouch, a lay-down pouch, a flat container, for example, for a chocolate bar, whatever it is, it's the same rules. Okay. So the same thing, and you declare it, it's right there. Strict rules or strict fines if you don't, for potential imprisonment. The reason they want to focus on this, there's two. One is, of course, is that you want to reduce the packaging wherever possible. But the other thing is it's more the first bullet here, where displayed in such a manner that a consumer might reasonably be misled with respect to the quantity of the product that they're purchasing. So, we all joke around about, you buy a bag of chips and you open up the bag and you're going, where's the chips, right? They're not the worst. We actually had a nice internal conversation a couple of weeks ago, and we focused. One of the things that came up was vitamins and supplements and things like that. So you buy a bottle of vitamins and you look down, and the bottom quarter of the bottle is that. Now, before we all go and yell at all of our vitamin and supplement companies in the world, bear in mind they have such strict requirements for labeling and et cetera, and seals and everything else, that it's hard to exactly focus them. And again, remembering that the golden design rules, there are special provisions for the medical field. So here we go.
Yeah, just before you jump ahead, question here is simply, can you define headspace? What are we talking about there?
Well, I'll show you right here on this slide.
Okay, perfect.
Timing. So you see the actual fill height, say the pouch on the left here, right? So you've got your total bag height. So you got where the zipper is here. I don't know if you can see a nice pink pointer on it. Does it show up on your screen?
It does, yeah.
Okay, good. So you see this line here. That's your zipper that you have across a typical pouch nowadays. And so that's the maximum fill height. So what they're saying is that 70%, it has to be at least up to 70% of the maximum fill height. So you can't read the numbers on it, but just, if that's 30 centimeters, then it should make sure that it comes up to at least 21 centimeters. So that's 70% of 30 centimeters. And then you can have this much space left over for your headspace in a flow wrap. So for example, with the chocolate bar, again, the same idea. Now this is a big chocolate bar at 30 centimeters, assuming it's the same 30 centimeters. I want one of those. That's a great chocolate bar. Anyhow, it's almost time for Christmas in Toblerone, right? So anyhow, again, it should come to 21 centimeters. leaving 9 centimeters of headspace, or in this case, in a flow wrap, dead space at either end, whether you measure from one end to the other, if the chocolate bar is floating in between it, the total combined space that's left that isn't filled can't be more than 30% of the package. So there, if you go online and you look at the Golden Design Rules, they've got lots of examples of what companies have done, both in wet and dry, stand up, bag, flat, all sorts of things. So there's lots of examples of where companies have changed their packaging. And it isn't necessarily even that they've changed it. What they're doing is, in some instances, they keep the same package because, of course, packaging size means shelf presence, which is really important. Of course, if you're not seen on the shelf, you're not going to sell your product. So shelf presence is really important. So shrinking the package down isn't necessarily a good thing from the perspective of selling your product. And of course, you don't sell your product, you go to business, and that's not sustainable either. So package size, what they're saying is, okay, if I say I'm going to use chips. I can get 150, I put 150 grams of chips in my bag, but I can actually get 200 grams of chips in my bag. Oh, okay, great. So what I'm going to do is I'm going to change it. I'm going to increase it to 200 grams. I keep my shelf presence, but now I got to change the price of my product. So there's different ways of going about it. It doesn't just necessarily mean changing your packaging and shrinking it, unless you're going to, but you just have to use the entire package, or at least 70% of the package. So here's an example on the right where Tide's gone. You actually see the old package. And again, this was an award winner from 2020 with PAC, our Global Leadership Awards. They changed from the bottle. What they did was they actually shrunk it. And it's like, think about it as Tide being served like a bag and box for wine, right? But they fill it right to the top. So there's very little headspace loss. There's no headspace loss in the bottle. And so it's a more effective use of space. There's a plastic bladder in there, of course, so the plastic is applicable. But by completely reconfiguring the shape, especially in this case for shipment in e-commerce, it's a safer package. They were able to reduce headspace. So they're just an example. Any questions on Golden Design Rule number 3? We have something in the chat box there, Andrew?
No, so far so good.
Okay.
Yeah, I'll let you know. But
Okay.
I'd say good to carry on to number 4.
Okay, good. Whoop. So Golden Design Rule number 4 is plastic overwraps. And the idea, again, is to reduce the amount of plastic being used. You can thin wall it, be a good place to start. Again, be careful that you don't move from a plastic, like a typical overwrap is polyethylene, and polyethylene is very recyclable. So it's not a problem. We want polyethylene plastic film. It can be recycled into more polyethylene plastic film. So it's best to use that. So don't look to move a plastic overwrap from, say, a polyethylene overwrap to something that's thinner and lighter, but you move it to, I'm going to use an extreme example, PVC, because we're not going to recapture the PVC. We don't want the PVC in the system, and it would be lost. So even though you're lightweighting in that respect, again, from the perspective of Ellen MacArthur, they're not looking at sustainable materials management as much as they are the packaging in the marketplace. Let's keep the packaging elements, the resin in the market, keep it going around the racetrack, right? So this Golden Design Rule applies to packaging overwraps that don't provide barrier layer protection. So we're not talking about your typical stand-up pouch where you have a PET outer layer, a polyethylene or polypropylene inner layer. This is just polyethylene for the most part. Bulk products, you may want to put them together versus a larger, or sorry, you see them as many together versus a larger size. But then when you put multiples together, now you got to wrap them. Well, now you're wrapping them, you're adding plastic to it. Well, or something else, what are you adding to it to put the bulk products together? The other thing, of course, is when you remove the overwrap, you must respect the health and safety concerns related if removed. So you can't just remove something and all of a sudden you've got containers, for example, with no labeling. You couldn't have that, right? So sometimes you see on the shelf, I've seen multi-packs where they've got a label on it and it looks like the same label as what's on the bottle. So it gives all the information, the labeling's on it. But when you take off that overwrap from the multi-pack, the bottle label is exactly the same. It's still got all the packaging information. So you have to make sure you maintain that. You can't just wrap up a bunch of mason jars, for example. and not have the information on it. That wouldn't be good from a health and safety perspective. So the other thing you might want to consider doing is changing the geometry of your packaging. So instead of going 6x4 into 24, in this case, you've even got an OCC liner tray with polyethylene shrink wrap around it. By zigzagging the 24 bottles, you remove the corrugate, which saves packaging weight, and then you shrink wrap around that. You reduce the footprint, you reduce the amount of packaging you're using, you reduce the amount of plastic you're using, which is what we want to do. But you're still maintaining the recyclability of the plastic, which is good. So that's just one example of what you can do for reducing packaging overwrap. The other one, and you're seeing more and more of this, is looking at alternative joining mechanisms for multiple packaging. So up on the right, we're not, like I said, I'm not throwing any companies under the bus. So here's just an example of, it's got what I would call, how do I put this, issues, shall we say. So they've got a plastic overwrap rather than say a cap overwrap like the Coke here. But the other thing they've got is a full body label on something. So if this was to go through, now in this case, this is an aluminum can, but there was another package right next to this, which was plastic bottles. Unfortunately, I couldn't get a clear enough cut picture out of it to use it without everybody knowing what the company was. So I purposely avoided using that one. But the idea is that it's a full body shrink label, which means if it was plastic, you couldn't see it. If it was kept in this format, if you break it apart, the labeling's got to stay the same underneath. But instead of wrapping in plastic, why not consider putting a corrugated cap on it, like Bud Light, another award winner from Pact with our Global Leadership Awards. This was a 2021 winner. Or what you do is you stick it in a 6-pack cluster pack, right? Or put a little plastic cap between, or handle between two bottles, makes it easier to carry. Or Coke, they've got the corrugated sleeve, boxboard sleeve that just slips over it, holds the cans together. And then finally, if I'm not mistaken, somebody can correct me if I'm wrong, but if I'm not mistaken, this was actually a Canadian invention, the Hdp Cap, which goes over multiple units of 3, 4, and 6. It was invented in British Columbia. And so those caps, when they come off, you can put those in your recycling box. They're HDPE, and we will capture them and we'll recycle them again. And they come in multiple colors. So it's, again, that's not an issue with that. So there's all sorts of different mechanisms of joining multiple units, which eliminate or reduce the amount of plastic being used and reduces overwraps altogether. So just a number of examples. Boy, my mouse is really being a pain today. Sorry, folks. Here we go. Okay, any questions on golden design rule number 4?
We're quiet right now, Dan. So I think we're okay to proceed to number 5.
Okay, great. Golden design rule number 5 is one that went through a number of iterations. A lot of work went into this one because this is one of those examples where what Europe is doing and what North America and specifically Canada is doing with their packaging is very different. PET thermoforms, they wanted, in Gold Design Rule number 5, the first time it was presented to me when I joined the expert panel, I was part of the team that developed these golden design rules. It said, yeah, you can have colored, you can have opaque, you can do whatever you want. Just look at maximizing recycled content in them, not a problem. And I'm going, hold on a second. Why are we doing that? They said, well, we can't do anything with PET thermoforms anyhow. You can't recycle them. You can't make bottles out of them. You can't do this. You can't. I go, whoa, slow down. Actually, you can. And they went, what? Again, calling out Ice River Springs. They're not the only ones, but they're the ones that brought it to my attention that through a special process, you can take PET thermoform, which can't be made into bottles if it was just PET thermoform. You melted it, made a pellet out of it. You cannot blow mold it into a new PET bottle. It just doesn't work. But by putting it through a special process, you can increase what's called the intrinsic viscosity of the thermoform up to bottle grade, and then you can blow mold bottles out of PET thermoforms. This is something that's unique to here. It's not being done it wasn't being done in Europe through the group. There was 42 companies, I believe, that were involved in the development of the Golden Design Rules. And so they watered down Golden Design Rule number 5 just because they had to address it, because there's just so many PET thermoforms in the marketplace. They had to do something. And I said, why would you do that? Why don't we look to increase the value of the PET thermoform to the highest possible end use, which means doing the extra process. It is economically viable. It's being done right now. It's going into a very low commodity valued, when you think about it, the Ice River Springs makes recycled PET bottles for single-use water bottles. It's something that's not got great value to it in terms of what you're selling it for. What do you buy at 24? I don't buy a bottle of water, but 24 pack of bottle of water for what, $3, $4, whatever it is. So, it's not like it's got great value to it, but in terms of being a perfect application for it, bottle to bottle, you take the thermoform, put it through its process, increase its IV, intrinsic viscosity up, and you can make new bottles out of it. So that's perfect. Why wouldn't you want to do that with as many PET thermoforms as possible, as opposed to downcycling it, what I would call, making more thermoforms or other PET products, which are all colored. And, again, you're not giving it the greatest opportunity to keep it in the system as many times as absolutely possible. And so I worked with the Consumer Goods Forum. There were a number of meetings, and they finally recanted. And I don't know if I know Jennifer's on the line from Loblaw, but her boss, Ian, calls us the Dan rule, because I was the one that pushed so hard. We finally got this upgraded so that Golden Design Rule number 5 really is about the same as the Golden Design Rule number 1. It just applies to thermoform. So no colored opaque PET thermoforms, same as the bottles. So we don't want to see, you can have, again, clear, light blue, light green only. Avoid anything with color in it. And so it's good. So now it's consistent, at least. And that's another thing that's really important about the Golden Design Rules, is they stay consistent from plastic to plastic. You don't want to have varying rules, because then it gets more difficult to understand and to apply, especially when you're trying to get your vendors to provide you with the right packaging. Well, if I do this and I can do this, but in this Golden, no, let's just avoid all of that. Let's keep the thermoforms at the same level as the bottles. And so that's what Golden Design Rule number 5 does. Again, same thing. Opaque PET is not recyclable into anything other than more opaque PET resin, generally black, must be removed before the clear can be recycled. So all you're doing is adding cost at the end market to get the colors out, or at the MRF level if they sort it out by putting in a color separation optical for PET to get the clear separated from the colors. Again, you're just adding cost to the system, but it doesn't mean you can't make PET opaque if you do get it into other, but if it's not there to begin with, now you've really got the opportunity to maximize the value of the PET. And really, that's exactly where we're going with these Golden Design Rules, is maximize the value. The people that need PET for being recycling it into more bottles, for example, are going to want to see this, because now they've got more sources of PET. A lot of our PET doesn't stay doesn't go for packaging, especially in the US. The PET gets sent offshore and gets made into textile. So just for an example, if people think of it like people know who Patagonia is, their jackets are recycled PET, just as an example. A lot of your carpeting is recycled PET. Well, if the PET is not available to be made into more packaging, then how are we going to meet our goals of the CPP and the Golden Design Rules of a 50% recycled content? We need more PET. So Keep It Clear has the best opportunity to be kept in the circle. Now, CPET, crystallized PET, is compatible and is acceptable. Now, you look at it, you're going, hold on a second, but it's white, it looks opaque. It is, but it's only because it goes through a separate heating cycle. When you're thermoforming it, that's what changes it to white. When you recycle it, it goes back to clear, and you can recycle it. The color is removed in processing because there's no color put into it. It's not actually a dye or an ink put into the PET. It's a process that changed it from clear to white. And so you can recycle it into it. So CPET, crystallized PET, can be used and is acceptable in a thermoform. That's where you typically see it. You see it in in quick service, in stores and that when they're serving food. So avoid the black. Now, a lot of time they're hinged with clear, but avoid the black, right? Again, remember, we can't even find it. So it's best just to avoid it altogether. And you're not supposed to use black unless it's discoverable, but in PET is the one plastic where it's no black, period, right? So there's no, it's not the exception. Sorry, it isn't that that black isn't acceptable in number 2, 4, and 5. It is, but they don't want black PET because we can't maximize its value. So go from black to go to clear, right? The one down here on the bottom left is a PET thermoform. This one, it's light blue, it's opaque, it shouldn't be used. There's another issue with this, which I'll explain in a few minutes, with this PET thermoform. So instead, move to clear PET in a tray format. Trays and thermoforms are the same. So move it in a tray format. So again, here's another award winner from PAC on our Global Leadership Awards for this year. And so they're using a clear PET tray, which is recyclable, and it's a better alternative from the black PET tray. Okay, any questions or comments on Golden Design Rule number 5?
Still quiet. We encourage everyone to throw your questions Dan's way on any of the design rules, but Dan, right now we're okay. So and it's, what is it, 10 past 11. Oh, question in, hot off the press. Any implications with labels on PET thermoforms?
Yeah, it's the same issue with PET thermoform. The labeling, it has to be completely removable. So if you're using an adhesive, that will not allow the label to be completely separated from the thermoform, that's going to cause an issue. Even if the label is PET, by the way, you don't want PET being stuck to a PET thermoform or to a PET bottle for that matter, and not being able to be removed, because then what's going to cause a problem in the recycling process is the adhesive. So if you use a PET label, that's fine, but it needs to be separable from the PET thermoform, and then it would go through the recycling process separately, but at least there's no contamination possibility from the adhesive on the label. Does that answer the question?
Perfect. Yeah, thanks, Dan. And that's it for now.
Okay. So Golden Design Rule number 6 is increasing recycling value in flexibles. So this isn't just stand-up pouches. This is all flexible packaging. So think about, a potato bag, a bread bag, even the liners you get in your produce department, anything, it's a flexible. But it also applies to the stand-up pouches. So these are multi-material, typically today, the vast majority, and I do mean vast majority, are multi-material, multi-laminated structures. Typically, they are poly or PET on the outside. They may have an aluminum barrier in there. And then they have polyethylene on the inside or polypropylene. There can be nylon, there can be all sorts of, or there can be EVOH. There's all sorts of different barrier layers that go into these stand-up pouches. The idea is to maximize the potential recyclability of films. And one of the reasons why we don't capture the pouches, for example, for recycling across Canada, or to be honest, anywhere, is that it isn't that we couldn't find them, but think about it. If a typical dog food bag is PET on the outside, and you can usually tell if it's PET because it's really shiny. So a PET outer layer and a polypropylene or polyethylene inner layer, then even if you could get it to go to the container side of the plant, that's another whole discussion for another day. When it goes through the optical sorter, it would eject off with the PET. But what would happen is it would have the polypropylene or polyethylene layer with it. When you go to shred it, now you're going to have a contamination of polyethylene because you can't separate the layers. It's not like, you could open it up and you peel it off. Like technically, if you think about it, you're really bored one day, take a little juice box and a Tetra Pak box, right? An aseptic container. Open it up. You could peel the paper and then the plastic, the paper, the aluminum, the paper and the plastic. You could delaminate it if you wanted to. You can't do that with multi-laminated plastic pouches. They don't delaminate. So you can't make a single stream of either PET or polyethylene or polypropylene as such without being able to delaminate. They're a contaminant one and the other. You can't put PET with PE and you can't put PE with PET. And you really don't want to put polypropylene in with polyethylene, even though they're both polyolefins. So strictly the golden design rule, again, remembering this was developed for a worldwide audience, not just a Canadian audience. And I'll explain, we have a slight variation that we're putting in for Canada, they need to be designed to fit within existing recycling programs. So existing recycling programs, for the most part over in North America, means polyethylene based. So that's why they've got that at the front. In Europe, they have a lot of polypropylene films and they will want to capture the polypropylene. So that's why it says fit within existing recycling programs wherever possible. Now, the second point is, if it's not acceptable, we need to look for a clear pathway for a future recycling by 2025, then the following requirements apply. Maximize the polyolefin content, preferably 90% mono PE. So in other words, if you're gonna have a multi-laminated pouch with a barrier layer in it, you would go PE barrier layer, but it has to be compatible with PE. And there are examples of that in the marketplace today, and another PE layer. Preferably more than 90%. And in fact, preferably, talking to the end markets, more than 95%. And if you can get even less than 2%, they're gonna be really happy. Keep it polyethylene. Do not put other elements in there that are going to cause a problem in the recycling system. Nylon, for example. There's other barrier layers. No aluminum foil, no PVC, no PET squished in there, even if it's only 10%. Don't put any of that in there. Keep it mono PE or mono polypropylene. That's the rule for the world. In North America, we would prefer to see a focus on mono PE because that's what we have the most of, and that's what gets recycled. The polypropylene is not compatible with PE in film recycling. 1 second, please. So in Canada, we want to see preferably 90% mono PE, not or 90% mono polypropylene. Let's keep it to preferably mono PE. Now, the minimum is listed here at 80% mono PE. Talking to the end markets in Canada, no, they don't want to see 80% mono PE. They want to see minimum 90%, like I said, preferably over 95% mono PE, unless it's completely compatible barrier layer inside that will not disrupt and remove or reduce the capability of the end market to produce a polyethylene pellet that can go back into more film, period. So that's the only exception. But again, it has to be compatible. There is a test that can be done through, it isn't done through the APR, but the APR has a testing guideline on there. And what they're saying is get it tested. If it passes, then you can declare it as being compatible and recyclable. If it doesn't pass, then you can't. And there are very strict rules in terms of, there's a lot of tests that have to be done. I won't get into it today. It's, again, I encourage you to look at the APR design guidelines in the US. They're available online, and you can take a look at all the testing that needs to be done in order to say that it is a recyclable polyethylene package. Density less than 1 gram, or less than 1 gram per cubic centimeter, is, in other words, less than 1, means that it will float. In other words, you're not introducing barrier layers or other layers in it that have polyethylene or polypropylene, both of which will float in water. But by adding nylon or PET, all of a sudden its density goes greater than 1. It means it sinks, and now it's lost to the system. So the idea is, again, to maximize recovery. Each barrier layer should not exceed 5%. That speaks to the preferably 95% mono. But each barrier layer like this should not exceed 5%. So you can't have 5% film, or sorry, PET and 5% foil and 5% EVOH and and 5% this. No, you can't have all that. They don't. Preferably avoid all of those things, all of them. You cannot limit the recyclability of the packaging. Look at the bullet number 4 at the bottom, or the footnote number 4. only use barrier layers, and barrier coating was proven not to limit recyclability of the packaging. So they list which the recommended ones are.
Dan?
Yes, sir.
Do flexibles include sleeves on containers?
No, that's considered more of a label.
Yeah. Okay. Good.
Okay.
Just in order to protect the inks, is an aqueous coating the best way?
An aqueous coating to protect, in other words, so that the ink doesn't wash off on the bottle. If I understand what that is, and I'm not positive, but if the coating on the bottle with the ink underneath, as long as when you put it through the wash cycle at the end market, the ink is removed so it doesn't cause contamination issues with the recyclable plastic behind it. And then if it's aqueous and it means it breaks down in water, then it washes away, then that would not be a problem. That would be a preferable alternative. If I've captured that correctly. If I haven't, please tell me.
Oksana, let us know if that helps.
Yeah, I was just thinking if because there's UV coating and aqueous coatings, etc. What is the less evil to be used? And I'm thinking it's aqueous, but I just wanted to check.
Well, if aqueous, like again, aqueous being it breaks down in water and washes away, reducing the opportunity for contamination in the recycled plastic, absolutely, that would be a better option. But again, if the UV coating can be washed away in typically, again, it's hot water or a slight caustic solution, then again, that would be an issue. If you're not sure with all of your coatings and barrier layers, again, before you're going to be able to say that a package is technically recyclable, and now notice I'm using the word technically recyclable, not recyclable, because by definition, plastic pouches, even mono-material pouches, if they're 95% PE, but it's a stand-up pouch, unfortunately, the Competition Bureau does differentiate between stand-up pouches and just bags, polyethylene films. They're now saying that the format has to be considered recyclable as well, which I'm taking them to task on that, by the way. As far as I'm concerned, if you've now got pouches in the marketplace that are technically recyclable, they should be called recyclable because they're now part of the film structure, not part of the multi-laminated plastic pouch structure, multi-laminated multi-material plastic pouch structure. And as such, that's two different things. Works to be done on that. Pouches are, well, they're not new, but they're newer in terms of packaging innovation. And they have a lot of benefits to being in the marketplace. But I think people are still trying to catch up with how to deal with them with respect to how to define them. But that's all part of it. But there is a test that is done through all the parameters of the testing are listed on the APR website. I encourage everybody to go there, take a look at it. I'm working with a company right now that just went through the process. It's not overly onerous, but the testing is very, very strict. And it explains exactly what has to be done and what you have to achieve to pass the test to be able to call your package a multi-laminated, multi-material structure. Now, multi-material in this case just means there's a barrier layer between two polyethylene films in order to call it recyclable. But again, they can't call it recyclable from the Competition Bureau perspective, just technically recyclable because now it's a polyethylene structure that passes APR testing. And APR testing is being used in the Canadian context. By the way, APR testing is also being used in the European context. So it's not like we're starting to create a North American only. There is another EU testing protocol. I believe it's out of Germany, but the APR is also acceptable. So Golden Design Rule number 6, choose monostructures wherever possible. Please, for the Canadian marketplace, focus on polyethylene only. The end markets don't want to see polypropylene. Now, again, from the perspective of the public, they don't know the difference. They don't know a polypropylene bag from a polyethylene bag. A lot of reusable grocery bags and that you're seeing in the marketplace, not just grocery, but in retail establishments. Those are polypropylene. Some of them are woven, some of them aren't. Those bags would need to be kept separate from the polyethylene before they're sent to market. Unfortunately, though, when the consumer is being told just capture your plastic and put bag in bag, for example, which by the way, they don't do, but if they did, it would be wonderful. But they just put them all together. And then that means that the end market now has to manage the polyethylene from the polypropylene, adding to their costs in order to get just the polyethylene resin available to make into new PET film. Avoid all other films, PET, for example, PET film. And yes, PET film is in the marketplace, but we don't want to see it. PET film is increasing in its use, unfortunately. But again, the public doesn't know the difference. And so what we're doing is we're adding in different resins in different applications, which are causing problem for maximizing the value and increasing the opportunity to have recycled content available for reuse and new packaging in the marketplace. And again, the Golden Design Rules and the Canada Plastics Pact, the big focus is on keeping the material in the stream, having the opportunity to keep it, put it back into the recycling system. So I got 25 slides. I got 42 slides in the deck. I guess I better keep going there, Andrew.
Yeah, I think we're tracking well, but yes, we're in the home stretch here, 11:25.
Yeah. So multi-laminated, multi-material pouches. You see them a lot in food products, snack foods, pet foods. That is not PET foods. Unfortunately, autocorrect. I forgot to catch that one. Remind me for the next one. That's not PET as in PET foods, but rather pet foods. It's amazing when you type the word PET too many times, your computer takes over for you. So animal food products, pet foods, snacks and treats, very commonly in there because of the oils, et cetera, that are in food. So they have to have barrier structures. The PETs on the outside, I found out, I was talking to one company and go, why do you use it? They said, because the odor. They can't, and this wasn't in a pet food application. This was in a laundry application. I'm going, oh, really? Yeah. They said, yeah, the stores don't want the smell of 15 different laundry detergents as people walk down the aisle. So what they have to do is put the PET outer layer in because it keeps the smell of the detergent inside the bag. Oh, okay. Learned something new. However, there are alternatives for many applications. There's a coffee bag on the far right there, which is now a monostructure. The one in the middle is a company, again, another PAC Canadian Award winner. And it's a monostructure with a barrier layer built into it. And in this case, it's got muesli. So again, that's something that has got oil in it, right? In terms of when they're making the muesli. So they have figured out, and they are using a monostructured bag, a stand-up pouch with a barrier layer built into it, which is able to hold this product. And there are a number of examples out there, but in this case, Hollows came out with this product and they won an award for it in 2021. So there are alternatives in the marketplace and encourage you to investigate further. Just quickly then, avoid the incompatible barrier layers and focus 90% plus on PE, preferable for the Canadian marketplace. Any questions on Golden Design Rule number 6?
No, sir. Onwards.
Okay, thank you, Andrew.
Yeah.
Okay, Golden Design Rule number 7 is increasing recycling value in rigid HDP and polypropylene. It isn't just those two. The reason they focus on those two there, so that's really 2 and 5. It does apply to number 4 as well, because a lot of the lids, for example, might be LDPE that are on the HDP tubs, for example. Same application, same rules. The reason PET isn't listed specifically is in Golden Design Rule number 1, these elements are shown as the second bullet point of Golden Design Rule number 1. So it's not like, oh, you can get away with whatever you want for PET packaging. No, that isn't the case. Rather, they're focusing very specifically on HDP and polypropylene, and there's a couple of reasons for it. And I'll show you in the pictures specifically. One is really about in-mold labeling, for example, and that's something that's heavily used in HDPE. So again, same application of the rule as in number 1. Make sure all your labels and material choice, adhesive choice, inks and sizes are not problematic for recycling. So again, not full body sleeves that are incompatible so that we can see it in the recycling facility. Like don't put a full sleeve PET on an HDP bottle, or for that matter, don't put a full sleeve polyethylene sleeve onto a PET bottle. So that what happens is if that's the case, then all of a sudden you've got PET bottles going down the HDP line in the MRF, or HDP bottles going down the PET bottle line in the MRF, which means now that the sorters have to pull them out separately, because if an optical sorter only sees it as one thing, now you need a human intervention to have that removed, unless you get to the point where you're going to have AI and robotics, and they're now going to start, oh, find me that product. I want that brand of product to pull that container out and put it over here because I want it now, go send it back over to that line. Gets very expensive either way you go, whether it's with AI or whether you're doing it with people, but don't make the sleeve so large that you can't, an optical sorter can't find the bottle underneath. Use minimal or moderate direct printing. Again, that's because we don't want to have the inks causing problems for the recycling process. Ensure that the closures are not problematic for recycling. Now, they don't speak really specifically to the liners in the seals, but if for a PET bottle, for example, don't put a PVC liner in it, because as soon as you shred the PET bottle and the liner gets pulled off, the liner is going to sink with the PET. And then all of a sudden you've got PVC mixed in with the PET. And as I mentioned earlier, now that's causing problems for the PET recycling. The same thing applies with PETG and PLA, all of those things, that they both all sink with PET. The same thing would happen with anything that floats. So preferably don't put polypropylene with a polyethylene bottle, because that's going to cause an issue. We want to be able to separate the two. Anything that allows the full separation of the specific bottle grade from the caps, the seals, the lids, whatever. Therefore, you're again maximizing the opportunity for recycling of all the materials. The other thing that's really big on this category is don't use fillers that increase the density of the packaging to greater than 1 gram per cubic centimeter. In fact, don't use fillers that, even if they don't increase the density of the packaging to greater than 1, this applies for other, that light blue thermoform I showed you earlier. That was actually a PET thermoform, but that PET thermoform had 40% calcium carbonate in it. Now, PET's already got a density greater than 1 gram per cubic centimeter, so it's already going to sink. However, the calcium carbonate at 40%, even 10%, you think about it, calcium carbonate is not plastic. Calcium carbonate is stone. You can't make plastic out of stone. Calcium carbonate is a contaminant that makes that package not recyclable. It will get recycled, because of my wonderful adage I've been using forever is dilution is a solution to pollution. Not a good adage, by the way. However, that's how a lot of these issues in packaging get managed today, is they dilute out the issue. Like the nylon in the PET, they dilute it by having a lot of really good PET to overcome the amount of nylon that's in it, so they can make more bottles out of it, because again, you can't delaminate these things. But it's best not to use anything that's incompatible with the plastic, or it's incompatible with plastics in general. So using calcium carbonate, talc, which is common in polypropylene, for example, don't use it, because you can't recycle or make recycled plastic out of something that's not plastic. So that's the big one. So the idea of the golden design rule is to maximize the value of the packaging and reduce the yield loss. I mentioned earlier about that mixed plastics bale that goes to the end market. And if you're lucky, they might get 50% of it coming off as 2, 4, and 5. They would love to see that up 80, 85% net yield. So if they're capturing, the HDPE, they're not capturing a lot of PVC and PLA and other plastics. They just get the HDP they want, or they just get the polypropylene they want, for example. Now, the same thing happens is when you think about it, just something to put in perspective. Now, this is HDP and polypropylene specific, but a very easy example for everybody to understand. A single-use plastic water bottle weighs about 9.2 grams. The cap weighs 3 grams. The cap is polypropylene. The PET, the bottle is PET. However, when you start thinking about, let's just assume the bottle is 9 grams, not 9.2. You send a bale of nothing but PET bottles to an end market. Even if they didn't have labels on it, the yield at the end market is now only 75% for PET, but the end market's paying, they only want the PET. They don't want the polypropylene. They will capture the polypropylene, but that's separate. But if they're buying PET, they want PET. So every time you add more materials to it, whether it be in labeling and printing and closures and seals, adhesives and fillers and liners and all those things that are incompatible with the bottle or the tub or the tray or whatever it is that you're putting in the marketplace, the jar, whatever you're putting there, if it's not compatible with the plastic that it's made out of, you're taking away yield. When you reduce yield, then you're increasing cost, and they have to manage it at the other end, whether they manage it and they can capture it like the polypropylene lids on the PET bottles, they can capture those, but having all sorts of different labeling elements and PVC and PLA and everything else that might be out there, and it would be lost to the system. Now, what are you going to do with it? You're not going to capture it for recycling. Again, that isn't consistent with the Golden Design Rules and the Canada Plastics Pact. So you have to focus on all the elements, because especially as we lightweight containers more and more, the weight of the label, the weight of the filler, the weight of fillers, sorry, the weight of the cap, whatever, really starts to impede on the net yield at the end market, which increases our cost and makes recycling more expensive. So a good cross-section, or sorry, a good cross-reference is the APR Packaging Design Guidelines. So just it's plasticsrecycling.org. I really recommend everybody take a peek at that, and you'll learn a lot about it, probably more than you want to know. But it's almost a whole course into itself with all these things for us to focus on it all here. So applications, instead of using a multi-material, multi-laminated, like that's you see metallized, plastic, all sorts of different combinations in there for a lot of tubes. Colgate, another award winner from PAC, with our Global Leadership Awards for sustainable packaging. Their packaging now is 100% recyclable HDP tubes. So it's great. They can go in there right next to the HDP bottles that are in the marketplace. So great move, right? In mold labeling, ensure that the in mold label is exactly the same material as the bottle. So in other words, you want to put a PE label on a PE bottle, or within the PE bottle, one of the layers, right? Avoid a full sleeve label. Now this is on a can, but it's the same thing that applies whether it's on plastic or otherwise. By the way, they don't like full sleeve labels on cans. If anybody's in aluminum cans, they really don't like the full sleeve body labels on cans either. So don't use those. Use a label on it, whether even if say this was a what's a good example? Tennis balls is a PET tube. It's got a metallized top on it, which that causes its own issues, but don't put a full sleeve label on that. Put just a label on it. Use a smaller label. That way we can see the bottle. It wraps around. That works just fine. Adhesives, avoid adhesives which are not water soluble or slightly caustic soluble. So in this case, this company, their label actually washes right off the bottle in a simple wash cycle. So it's great. Now this is a glass bottle. It can be a plastic bottle. I've seen examples there. This was just a nice example to show you of it breaking down very quickly in a wash cycle. There's that wonderful punnet with the filler in it. Calcium carbonate renders the package non-recyclable. Make sure it's compatible and make sure it doesn't change the density from less than 1 to greater than 1 if you're using something like polypropylene, which floats out, and then now you've changed it so much that it now sinks, and you've lost it to the system. Caps and closures, avoiding incompatible caps. The cap liners really aren't in scope. We can't capture them in a recycling system. They'll get captured at the end market. If those little caps come through my MRF, what'll end up happening is they'll end up with the glass. So make sure you're not doing that. On the right is a check mark. Those are polypropylene shrink sleeves for the top. If they were PVC, and again, you put a PVC shrink sleeve onto a PET bottle, or then that's going to cause a problem. You put a polypropylene cap or shrink sleeve on top of a polypropylene bottle, then you've got no problem. It's compatible. It won't have an issue with recycling process. Okay, I see we have some questions, Andrew.
Yeah, well, real quick, a comment from none other than Alan Blake, PAC Next US director who joins us today from the UK. So I just direct everyone's attention to the chat, a helpful comment from Alan there about reverse printing on monomaterial structures. And then a question from Todd. For the toothpaste tubes, does the residual paste cause problems? I remember reading, in fact, that it's, I think Colgate said it's even a cleaning benefit, but Dan, any comment there?
Oh, I could make up all sorts of bad jokes about, oh yeah, we end up with no cavities in the bottles and things like that. I don't know if it really helps much when you think about how many toothpaste tubes you have in a bale relative to all the other plastics you get. However, I'm not going to dispute what Colgate's saying because I haven't investigated. But I would suggest that when you put it through a hot water cycle, think about when you have your own, when you brush your own teeth, what happens to the toothpaste? It breaks down, it washes away, right? So I don't think it's a strictly an issue, shall we say, but helping?
Yeah.
Often further
touch.
Yeah. Right, shiny, shiny white bottles.
So that's it for now, and we're just shy of 11:40. So I think we're right on track.
We got 10 slides left to go, so it's perfect. Okay, so Golden Design Rule number 8. This is not from now for consumer-facing packaging. This is business-to-business packaging. What they want to see is a tremendous reduction in the amount of virgin plastic that's being used in business-to-business. So wherever possible, eliminate it. Now, I'll give a couple of examples in a minute. If you are using or have to use plastic in an application, wherever possible, switch to post-consumer alternatives. So in other words, you're not using virgin plastic sources. Even virgin plastic, if it was bio-based, still would be in many applications, considering what the value is of what you're putting into the market from a business-to-business perspective. Does it have to look really pretty? What's it doing? What's its application, et cetera? Can you use recycled content? In all likelihood, yes. Or alternatively, this is Andrew's favorite line in the entire Golden Design Rules is 8C, switch to reuse models or alternative materials. So especially the first one, switch to reuse models. So eliminate unnecessary plastics, look to reuse, and use recycled content.
I'm getting a t-shirt with 8C printed on it.
Yeah, I'm sure you will. So reusable wood is best. Your typical CHEP pallet, for example, on the left there, they go around and around and around, and when they break, they just go and they get recycled or chipped, and the CHEPs get chipped, and then they, you can get a new one. But there's no plastics use at all. It comes from renewable resources, so that would be your best option. If you're going to use plastic, both of the examples on the right, or the center and the right, are recycled content. I know that maybe the one on the right doesn't, but you can color separate out the plastic. Those are recycled content. If you really look closely, all the blues are a slightly different color. That's because of inconsistencies in the batches. But recycled content, reusable crates, if you can use those, great. The palette, you can see that beautiful, beautiful Jackson Pollock painting on top of that. No, I'm just kidding. Jackson Pollock palette there with all the different colors on it. And it's obviously recycled content. So again, you're not using virgin resources for something that is just going from your distribution center to the store and return, et cetera. You know what I think I'm missing in here? Yep. My apologies, folks. There you go. There's our first oops of the day. Somehow we managed to miss Golden Design Rule number 9. Golden Design Rule number 9, I'll speak to it. So make note, everybody. How in the world 4 of us all missed this? That's a good question, but anyhow, we did. Golden Design Rule number 9 is for on-pack labeling of all of your packaging. Now, there's not a lot of uptake right now in the Canadian perspective for on-pack labeling of plastic packaging because, as I mentioned earlier, the plastics packaging in Canada, with the exception of multi-laminated plastic pouches, is considered recyclable by strict definition of the Competition Bureau, which says 50% plus 1 of the population has to have access to it. When I did a study a couple of years ago, I looked at access to plastics recycling in Canada. The top 10 cities, towns, whatever, in each province all had access to all plastic packaging recycling with minor exceptions. For example, there might be a municipality that says no black plastic. However, that's a color separation. That's not a resin separation to say not recyclable. So therefore, putting a label on your plastic packaging in Canada that says, you know, put it in your blue box would be completely redundant across the country for the most part. Now, there are some regional differences. For example, plastic film and multi-laminated plastic pouches in British Columbia go through a depot network where they go through curbside in other jurisdictions, other provinces in Canada. But again, those are the exceptions rather than the norms. The other thing to bear in mind is, and the concern for Canada is that everything has to be bilingual. It takes up a lot of space, and it really isn't adding value when you consider that, again, all of our plastics are considered recyclable. So what message are you giving to the consumer in terms of putting a label on a package? Now, I'm not saying don't use it. However, it's different in Canada than it is from other jurisdictions, especially in the United States, where it's a more disparate breakdown of all of the different what's recycled where for plastics. So it makes more sense in the United States to use how to recycle labels. The other thing to bear in mind is that most of our packaging in Canada is not made in Canada. So that means now you have to get packaging producers to put the labels on specific Canadian containers, which can be quite onerous, particularly if you've got INMO labeling and everything. So it gets very complicated very quickly. Again, I'm not discounting that you shouldn't consider them. However, within the Canadian context, it might be considered a little not as necessary as it would be in other jurisdictions around the world. So my apologies. I can't believe that all of us missed that. So from PAC, I apologize on behalf of our entire team that went over this deck, goodness knows how many times. And it will be in for any future things. So this is not in the Golden Design Rule specifically. I've adapted this. Oh, sorry, before we go on, Andrew, any questions?
No, just to note that Lindsay has included a link in the chat. So just take note of that if you want to grab it before the Zoom meeting ends.
Yes, yeah, where you can get the Golden Design Rule number 9. Can't believe it.
Yeah.
Anyhow, so when to follow the Golden Design Rules. Now I've adapted this. The top box is actually not the top box that you'll see if you look up the Golden Design Rules, but this is specifically related to Golden Design Rule number 5. However, as I mentioned, Golden Design Rule number 5 was developed again, as were all of them, for an international audience. We got it adapted to recognize highest and best end use, which is good. That's good for everybody. But the compromise when the Golden Design Rules were being presented was, I don't like that. I don't want to do that. So what can I do? And so what they said was, okay, here's what we're going to do with following Golden Design Rule 5. And I thought, from my perspective, it makes more sense just to follow it for any of the Golden Design Rules. Are there regional design guidelines for the plastic resin and applications so they fit within existing recycling programs? And is it possible to follow the guidelines? Now, as I just mentioned, plastics are being recycled across Canada in most jurisdictions. So therefore, the answer should be yes for almost everything except for, again, multi-laminated, multi-material plastic pouches. So if that's the case, yes, follow the regional design guidelines. So regional, in this case, regional really does mean Canada because we don't generate packaging for, Nova Scotia and Quebec and Ontario, Manitoba and Saskatchewan, et cetera, and BC, blah, 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 across the country. We just develop them for Canada if we're lucky to even have Canadian packaging as opposed to North American or even worldwide packaging for that matter. So generally speaking, it should be yes. Now, if it's no, is there a clear pathway for future recycling by 2025? So this is where I would, encourage people to look at the likes of maybe what's happening in Quebec for polystyrene, or in British Columbia for multi-laminated, multi-material plastic pouches, or elsewhere, what's happening, the Holy Grail for plastic films and pouches, et cetera. Is there a clear pathway for future recycling? If yes, by 2025, then start developing your packaging and change your packaging to follow the Golden Design Rules. If no, then the Golden Design Rule is not a requirement. Now, one huge caveat in all of this is the Golden Design Rules are voluntary, just as CPP is. But with all of the great members that we have at the CPP level and that we're developing the golden design rules, there are a lot of huge companies involved. If we get everybody on side, then we're going to really see a paradigm shift in terms of plastic packaging, which is going to be good for everybody, and everybody will follow along simply because it makes sense. Companies are going to put plastic packaging in the marketplace that the consumer wants, and as their sales increase and plastic packaging the consumer doesn't want is frowned upon, the companies that aren't following it are going to have to, you saw it right from my first slide, 64% want to see recycled packaging. So therefore, develop your packaging accordingly and follow the golden design rules so that no will quickly move over to a yes. Okay, so that's all for the golden design rules, but people look at their packaging, and what I wanted to introduce for the last few slides is something that PAC's developed called the Packaging Innovation Pathway PIP 360 model. PAC has developed a circular benchmarking tool. So you look at your package and you're going, well, I don't know how I'm doing. How circular is my package? I really need to understand where I stand today and what should I be doing or where should I be focused? So PAC had developed PIP 360. And what it is, it's a circular benchmarking tool that examines material composition. So whether it's made from recycled content, whether it's made from bio-based sources. And oh, by the way, PIP 360, I'm going to say right up front, it doesn't look just at plastics, it looks at all packaging. So if you're looking to make any of your packaging, whether it's plastic, paper, metals, glass, whatever, more circular, PIP 360 looks at all of them. But we look at material composition, including recycled content. Remember, you've got the CPP goal, 50%. Level of reduction, so how much you've reduced your packaging. So think about that like golden design rule number 3. And the recycling rate. The recycling rates that we use are those that are posted for the provinces in Canada under EPR, with the exception of we don't have Saskatchewan and British Columbia, but we have Manitoba, Ontario, and Quebec data. It's real, it's posted, you can look it up yourself. And what we do is we score your package looking at these elements. We calculate a benchmark score, but then we provide pathways to circularity. So we say, your package hasn't been reduced at all. So look at reducing your packaging, your score will go up. Your packaging is not using recycled content. We suggest you look at recycled content or bio-based sources. If you do, then your recycled content, your score will go up. Your recycling level, the recycling rate for your package is at X. Will tell you in order to get to 360, you need to increase your recycling rate. Now, I appreciate that packaging producers and users don't control the recycling side of it, but they can, in some respects, think about unpack. Tell the public what to do with their package when they're done with it, or just make it more recyclable. In other words, put it into 1, 2, 4, or 5 plastic, gives it a better chance that it's going to be recycled. You saw those recycling rates at the beginning. PET and HDP are already over the 50% mark. Let's keep that momentum going. You focus on those plastics, then you're going to hit the targets that we want to see for plastics packaging under CPP and the golden design rules and Ellen MacArthur. So it looks at plastic materials consistent with the golden design rules and the Canada Plastics Pact. And also we calculate the key CPP reporting category percentages of what percentage is recycled content and what is your recycled rate, not recyclable rate, recycled rate for your plastic packaging. We can give you all that. It's all included in the tool and it'll give you a score. So in version 1, which is online right now, there are 17 plastic packaging categories. In version 2, which we're just about to send to the FileMaker expert to build out the model, we're moving to 36 plastic packaging categories. So this has been vetted by CPP and by all of our technical committee and our leadership team. We looked at it and said, this is the list of plastics we want to see shown and scored against, because we're going to need to record all this and report back under CPP against these categories. Maybe not all of them for CPP, but we definitely want to know for our own uses as retailers, consumer goods companies, or anyone that wants to use packaging converters, packaging producers, packaging designers, whatever we want to do. We want to be able to record against these materials. So we report on the plastics elements. So there you go. There's a little snippet. It's not it's Excel based right now because I'm working on finalizing it. I developed it in Excel and then I gave it to FileMaker. It's all an online tool. You don't see it. It's not an Excel spreadsheet. It's much more fancier than that. I don't do fancy. I do the technical side. But we got a fancy person. She's great. She developed and built the online tool first. The first one that's online now. And we're going back to meet with her actually tomorrow about getting version 2 built out. So we've got, what we do is we show your plastic elements in total weight, and then we look at what's your recycling rate, or in other words, what percentage has been recycled, and what's your recycled content elements. So this is just an example. In this case, it was a 24 pack of water bottles. So here's what the scoring looks like, and thank you to Silgan for this. They are one of our early adopters. They love it. They're using it all the time. And they show to people what happens when they run their materials through the PIP 360 model. So they start with 100% virgin HDP. They get a score of 65, and then the pathways are shown. If they move to lightweighting their package, that's what LW stands for. The 100% virgin HDPE, their score moves up to 83. So it's a bump. It gets there a little bit. And then the third iteration of their package, they say, well, what about if we start incorporating PCR into our plastic package? And this is an HDP bottle. And it goes up 25% PCR into the HDP, and their score jumps to 123. Now, we are asked, all of us at PAC, can you get to 360? There's a package in the marketplace that scores a 352. So yes, the answer is yes, you can get to 360, but it's not plastic based. It's corrugated containers, score of 352. So it's very possible to get to 360. The score is out of 360. So we can get the circular packaging. And we give you the innovation pathways to circularity. Version 2 is going to have even more detail in there. And we're really going to help drive a circular economy through the model. Finally, we're available. Contact myself, contact Alan and Andrew. At any time, we can help with the scoring of your packaging. We can help you understand what the PIP 360 model is all about. We can help you with what the gold design rules are all about, what CPP is all about, and get your packaging consistent with the golden design rules and CPP. So please, by all means, reach out to any of us and ask us for more details. Last slide, and then Lindsay's going to put up a survey for us. The golden design rules are voluntary under CPP. The targets on recycled content recyclability means adopting golden design rules will help in achieving the targets. I know I just read it, but the idea is that by focusing on specific plastics that are more desirable by the marketplace and easier to manage and recycle in the marketplace, we're going to drive capture, have higher yields at end markets, drive our costs down, increase the potential material available to put into recycled content, which then we drive back through the economy, and we keep the circle going. That racetrack just gets bigger and bigger and fuller, and that's really where we want to see, is higher recycling for PET, HDP, low density polyethylene, LDPE, and polypropylene. So, Lindsay, do you want to throw up a survey, and then we'll take final questions. I think we've got about 5-6 minutes.
Yeah, we can take questions. There won't be a survey popping up on your screen at this moment, but you should all have a survey, an electronic survey in your inboxes currently. We would really appreciate your feedback if you could just take a couple minutes to complete that for us as we continue to build out this program. We also have included in that email some more information about PIP 360, the consulting services PAC's now offering with our PAC Next team, and our upcoming Golden Design Rules workshop in person at PACX Toronto on November 10th, as well as a PAC Packaging Circularity Education course on November 30th and December 1st. So that's all in your inbox. If there are any questions after the program, feel free to reach out to myself or the PAC Next team, and we'd love to follow up with you.
Thanks, Lindsay. Andrew, do we have any final questions? I think we got a few minutes left, right?
We have 3 minutes before
Perfect.
lunchtime, if one's in the EST time zone. And it's actually from Alan. Are the GDRs fixed, so to speak, or do you expect them to change in the future given potential new innovation and technology?
I think they're going to evolve as packaging evolves, as opportunities evolve, as recycling technologies evolve. Like right now, chemical recycling has tremendous potential, but it just isn't at scale. There's over 100 chemical recycling companies out there. And as they are able to manage different and more types of plastics, then I think you're going to see opportunities for plastic packaging evolve along with them, with the capabilities of managing at the end market, respecting we still have to get it through the MRF to capture it in the first place. The other thing, of course, the big thing that's missing out of the Golden Design Rules right now is the compostable packaging, compostable plastics. And that requires a tremendous amount of time and effort. It will come, but right now, because the technology for processing it is just, MRFs are, every one of them is unique, but at least the core technologies are similar now between facilities. In composting, they're very different between the technologies. And as such, it just takes an awful lot more work to get from point A to point B on that one.
That's, I think that's a perfect way to close. No further questions in the box. We're a minute to the hour. So over to you, Dan, for a last word.
Well, thank you very much, everyone. I appreciate the time that you've taken today to learn more about the Golden Design Rules. As Lindsay said, if you have any further questions, please don't hesitate to reach out to any of us. Reach out to George as well. Thank you again, George, for helping with this and participating on this Golden Design Rules training. If there's anything any of us can do, don't hesitate to call. And thank you very much for your time today.
Yeah, thanks, everyone.
Thank you, everyone. Enjoy the rest of your day.
Be well, stay safe. Talk to you soon.
Bye now.